All right, so I wanted to just finish up this one quick example with you guys. Okay, so we were looking at this example where we were told that we want to have a leading coefficient of 1, build a polynomial, leading coefficient of 1, so that makes things easy. We were told that we had the two zeros, 1 minus the square root of 2 and 2 plus 4i. And you guys correctly told me yesterday that that implied, okay, we had to have each of those had to come in a pair, conjugate pair, right? Because this one is non-real, right? So that's part of a complex conjugate pair. And because this one got stuck with a square root, so that's also going to be part of a conjugate pair. So we get these other two for a total of 4 zeros. And now our job is just to multiply all those out, right? So we know from our factor theorem from yesterday, let's go back and just quickly review that. Right there. Our factor theorem just says that if k is a 0, then x minus k is the corresponding factor, right? So if k then would be replaced by 1 plus the square root of 2, then the factor would be x minus that number, x minus the number 1 plus the square root of 2. We got to put that in parentheses, of course, right? Because we're subtracting the whole thing. And then we'd get x. Let me make some arrows here. So this one, whoops. So that one gives us that factor. That 0 gives us that factor. What's the factor that's going to go with the 0, 2 plus 4i? There you go. X minus the quantity 2 plus 4i. And then finally, last factor, x minus the quantity 2 minus 4i. Okay, we got a product of all four of those things. Now that looks pretty bad, right? Because what am I going to do here? I'm going to have to probably distribute that negative sign, right? And then there are no like terms to add up, but I distribute that negative sign. Let's do that. So if I distribute the negative, I'm going to get what? X minus 1 plus the square root of 2. Here we're going to get x minus 1. If I distribute, I'm going to get minus the square root of 2. Here we're going to get x minus 2 minus 4i. And here we're going to get x minus 2 plus 4i. Okay, everybody good with that? Okay, that looks like a lot, right? I mean, think about that. I've got 4 factors to multiply together. I can multiply those in any order I want to. Every time I multiply 2 of these together, it looks like I'm going to have to distribute 3 terms to 3 terms, right? That looks like a mess. Okay, but there's a great trick here, right? Whenever you have zeros that include 2 terms, like we do, right? Each of our zeros are conjugates, and they each include 2 terms, right? There's a trick. After you distribute, you can regroup to make both of the orange and the blue factors look like conjugates, okay? So do you see a way to do that? Do you see a way to make these two look like A plus B and A minus B? Do you see a way to make that happen? Make this one look like A plus B and this one look like A minus B? How could I group those to make that happen? What could I choose for my A and my B? If x is a, you're saying could you could you substitute x for a? It doesn't seem to work though, does it? Because then I get, what's my b? So one of those two, I've got three terms here, right? And I'm only choosing an a and a b. So either the a or the b, one of those two is going to have to include two terms in it. So we could try that, right? If I did -1 plus the square root of 2 is b, then negative b would be the opposite of that, which would be +1 minus the square root of 2, but that's not what I have. See what I'm saying? Do you see the same thing for the first term and the opposite thing for the second term? Is there anything that's the same in both of those? Because that would be a. X minus 1. Yeah, look at that. What if I regroup this so a is x minus 1 and b is the square root of 2? That works, doesn't it? Right? If I distribute the negative and I regroup the first two terms, look at that. I get a equals x minus 1 in both of those, and I get b equals the square root of 2 in both of those. You know, I've got a plus b and a minus b. Everybody see that? See how that worked? That's pretty tricky, right? Because now when I multiply those together, I can multiply those like conjugates. What's our conjugate pattern again? If I multiply a plus b times a minus b, what is that always equal to? A squared minus b squared. There you go. If they're complex conjugates, it would be a plus, right? If they're regular conjugates, it's just real number conjugates, then it's a squared minus b squared. Well, we can do that. Look, that's just going to give us then all the orange stuff here. If I multiply a plus b times a minus b, that's just going to give me a, which is x minus 1 squared, minus b squared, right? Well, square root of 2 squared is just 2, right? Pretty good with that? Okay, and this is something that's easy to do. We can use our pattern for that, our a plus b quantity squared pattern, right? So let's keep going down here. What's that look like if I square out x minus 1 quantity squared? Remember, if I square out a plus b quantity squared, what do I get? A squared plus 2ab plus b squared. Okay, so then this is just going to give us, when I square this part out, just right here, I got to kind of color code this. If I just take that part, I'm going to get x squared plus 2 times x times -1. Isn't that minus 2x? Plus -1 squared, well, that's plus 1. And then I've got minus 2. Everybody agree? And I just combine like terms there. Plus 1 minus 2 is minus 1, right? So all this stuff just becomes x squared minus 2x minus 1, right? And it's pretty convenient. It doesn't take much work. That would have been a heck of a lot harder if I had had to distribute the x all the way through and the -1 all the way through and the square root of 2 all the way through and then add up all the like terms. That would have taken a lot longer, right? Okay, now we can do the same thing. Here, let me move this out of the way. Oops, that's not. Oh my goodness, come on. Why is it not letting me do that? Well, I'm just going to erase that. You guys know that pattern. Okay, now we're going to do the same thing here, right? We're going to regroup these in the same way. Look, if I regroup the first two terms after I distributed the negative sign, oops, there we go. If I regroup those terms, doesn't that look just like A minus BI times A plus BI, where A is x minus 2 and B is 4, right? Everybody agree? And if I multiply out complex conjugates, I get A squared plus B squared, right? So then when I multiply this whole thing out, I'm going to get A squared plus B squared, right? Okay, now we can do the same trick, right? X minus 2 quantity squared. Well, we can do that. That whole thing, what's that going to become if I square that out, everybody? X minus 2 quantity squared. Okay, I get x squared minus 4x plus 2 times x times negative 2 is minus 4x plus 4. And then here we just get plus 16, right? So if I combine like terms, all the blue stuff is just going to become x squared minus 4x plus 20, okay? And then from there, now all I'd have to do is just distribute each orange term to the blue terms and add up like terms, right? That makes sense? Which I guess, let's just practice that real quick. It's the last thing we're going to do, and then I'll let you guys work. So then that would equal, if I distribute the x squared, I'm going to get x to the fourth minus 4x cubed, good. And I'm going to make sure I keep a column for each power of x, right? So we can add things vertically. Good. Okay, so plus 20x squared. What's going to happen if I distribute the negative 2x to everything? What's that going to give me if I do all that stuff, Mackenzie? If I distribute the negative 2x? Oh, I got that. Good. Okay, so I'm going to put it in that column, and then what power of x? Oh, squared. Okay. And then finally, okay, good. And then finally, if I distribute that negative 1, Trenton, what's that going to give me?
Negative x squared positive 4x negative
Minus 20. Okay, good. And so if I write the whole thing, then I'm going to get for my final answer, we'll do purple, I guess, huh? So we end up then with our final answer is just going to be what, x to the fourth? How many x cubes, everybody?
1, 2, negative. Oh, 6.
Negative 6, there you go. Minus 6 x cubed. How about the x squareds? 27, I heard. Is that right? 28 minus 1. Okay, so plus 27x squared. What's that one? Minus 36. Minus 20. Done. How about that? That's probably seemed like a lot of work, but I tell you what, that's a lot more efficient than if we hadn't regrouped like that. That's a great little trick. Okay. All right. And that one's kind of a bonus question. I mean, there's a lot there, but you should try it. Try it on the homework and try it on the test. It's good practice. If you go on in math, you'll do more of that. And I know you're all going to go on in math, right?